Hello and welcome to this section on machines. These are some topics we're going to be looking at in this video. What are machines? How are simple and compound machines different? What is efficiency? How are machines useful? And what is mechanical advantage? And I know you've seen this from the Rube Goldberg machine from our last video. Certainly machines can be a little bit more useful than that, I think. So the definition of a machine is any device that changes the force or increases the motion from work. We just talked about work. We know work equals force times distance, force through a distance. If either the force is changed or the motion is increased, well, that's a machine. This ramp is a machine right here. Imagine these three men trying to lift that piano up into that truck without the ramp. It would be very difficult. They could use a pulley system as well. That would be another type of machine. Let's say you're interested in increasing the motion instead of changing the force. A bicycle would be a really interesting machine for you to be using. Now let's look at the most simple machines. Simple machines are machines that do work with only one movement of the machine. So a bicycle would not be a simple machine. But these 6 machines are simple machines, and I'm sure you recognize all of these from middle school science class. So we are not going to go in great detail with all of the machines, but you do need to know what the 6 simple machines are. We have a screw, a lever, you can see being used there, pulley, an inclined plane, a wedge, and a wheel and axle. A compound machine, then, is a combination of 2 or more simple machines. These are both examples of compound machines. You should be able to recognize 2 wedges here, as well as 2 levers on the scissors. So those actually combine 2 wedges and 2 levers. The bicycle is a compound machine. It combines quite a few different simple machines. Now let's talk about efficiency. When we talk about machines, we'd like to talk about efficiency, and that's the ratio of output work to input work. It is very important to note that you can never get more output work than you can never get more work out of a machine than you put into it. It's impossible. Remember that a machine increases force or increases speed. It cannot increase both at the same time. Therefore, no machine, because it cannot increase both at the same time, you cannot end up getting more work out than you put in. You will get actually less work out than you put in. A way to think about that mathematically, can look at percent efficiency. What's the percent efficiency of this machine? We can look at the work we get out of it in joules, divided by the work that we put into it in joules. Take that whole thing, that fraction, multiply it by 100, and that gives us the percent efficiency for our machine. This is a simpler way to write it, if you're comfortable with that. Little e for efficiency, and percent efficiency is the work out in subscripts, divided by capital W for work in times 100. And remember to always divide those together and get an answer first before you multiply by 100. Work in is always greater than work out. Let's do a sample problem together. What is the efficiency of a ramp if the input work is 96 joules and the output work is 24 joules? So we're just writing our equation here. Efficiency equals the work out divided by the work in times 100. We can substitute the values from our problem. The output work is 24 joules. So if we write efficiency equals output work is 24 joules, and we want the output work on the top. So put 24 joules on the top. And we also see that the input work is 96 joules. The work in we want down on the bottom, so we put 96 joules on the bottom. Next, we need to remember to multiply by 100. Now when I punch into my calculator 24 divided by 96, my calculator is kind of dumb. I don't put joules in there, but you understand those will cancel out. 24 divided by 96 equals 0.25. When I multiply 0.25 by 100, I get 25%. So the efficiency of a ramp with these parameters is, or with these kinds of the input work and output work, is 25% efficient. So remember, all machines are less than 100% efficient. So if you're ever calculating efficiency and you get a machine that is over 100% efficient, you did something wrong. You probably flipped the input and output work in your equation. How could we increase efficiency of a machine? Usually, the efficiency of machines are greatly reduced by the amount of friction that is going on. So reducing friction will usually help to increase efficiency. This is definitely a topic of great interest to engineers who are trying to build better machines. There's a lot of work that is done in increasing efficiency of your car, a very complex machine, or a lot of other machines. It's an important topic, and a lot of people do this for a living and make their living trying to think of ways to make machines more efficient. So let's look at some examples of how machines are useful. They increase speed. We've talked about that. How do they do that? Here's a bicycle. Bicycles are machines that increase speed. But in order to increase speed, the bicycle decreases force. The bicycler, he's probably going to get tired because his legs must apply a larger force to get the pedals up the hill. Some machines change the direction of force. This wedge-shaped blade on the axe is an example. You exert a downward force on the axe to split the wood. The blade changes this downward force into outward forces that split the wood. Some machines are useful because they increase force. This car jack is an example of that. It increases force, but it decreases speed. The upward force that is exerted by the car jack is greater than the downward force that you exert on the handle, but you definitely are moving the car jack handle faster than you lift the car. So this car jack that we were just discussing is effective at increasing force. How effective is it at increasing force? Well, one way to measure that is using this term, mechanical advantage. Mechanical advantage gives us an idea of how effective a machine is at increasing that output force. It is the ratio of the output force to the input force. So when we talk about mechanical advantage, it is equal to the output force, and remember force is measured in newtons, divided by the input force measured in newtons. Another way to write this, mechanical advantage, capital M, capital A, is equal to the output, the force out, little subscript out, and capital F for force, divided by the force in. Let's look at an example for some mechanical advantage. A crate weighs 950 newtons. If you can use a pulley system to lift that crate with a force of only 250 newtons, then what is the mechanical advantage of that pulley system? Let's start by writing our formula. Mechanical advantage equals force out divided by force in. Now we can plug our values in here. We can say mechanical advantage equals, now which is the force out and which is the force in? If you're confused, just think of it. We have our pulley system here, and it's lifting this crate with a force of 250 newtons. So that is the force that it is using to lift that crate. The force that we're actually getting out of this is 950 newtons. Remember, weight is a measurement of force. So in essence, we're getting 950 newtons of force out of this, but the pulley's only putting 250 newtons in. When we multiply this out on our calculator, we get our mechanical advantage to be equal to 3.8. So what does this mean, and does this make sense? We don't use units with measuring mechanical advantage because our units cancel out. This number is very close to 4, and if we look at the weight of the crate, it's very close to 4 times the force needed to lift it. So the mechanical advantage is very nearly 4. 250 times 4 is just about 1,000. So this does make sense for the mechanical advantage. So in review, what's a simple machine? What are the 6 simple machines? What's a compound machine? How do you calculate efficiency? How do you increase efficiency? How are machines useful? And how do you calculate mechanical advantage? Those are all the things you really need to know. If you are feeling like you want to go for advanced proficiency, you need some more challenging things to do, here's some ideas for you. Read through these and see if you'd like to take one of those ideas and go with it and find out the answer. And I look forward to seeing you in class.